Hello everyone, welcome back in Arena World Education. Here we make mathematics easy and interesting. Let us continue the chapter Complex Numbers. Today we will explore many different topics of this chapter. So be ready with your pen and notebook to write down important concepts. We have already completed one topic of complex number. So let us start with quick recap. If we talk about complex number, so how to represent a complex number? It is very easy. A complex number is represented as z is equal to x plus iota y. Here x is called real part, y is called imaginary part, and iota is what? Iota is an imaginary unit, right? And iota y together, so they will call imaginary number. What is the value of iota? Yes, it is equal to under root minus 1. Now, next thing is Argand or complex plane. Argand or complex plane is used to represent a complex number. If we want to represent complex number graphically, so then we use Argand or complex plane. You can see this is the Argand plane, right? This is very much similar to coordinate plane. The only difference is here x-axis are treated as real axis and y-axis are treated as imaginary axis, right? If we talk about quadrants, so same we will follow. It will be first quadrant, it will be second quadrant, it will be third quadrant, and this will be fourth quadrant, right? In first quadrant, yes, both will be positive. In second quadrant, x will be negative, what y will be positive. In third quadrant, both are negative. In fourth quadrant, x will be positive and y will be negative, right? If we talk about a complex number, so here z is equal to a plus iota b. This is a standard notation, right? And if we represent any complex number in the Argand plane, so what we will do, we will check this a comma b will lie in which quadrant, right? So accordingly, we will represent any complex number in this Argand plane. Let us understand, suppose we are having 3 plus 2 iota. It means if we compare this with what? A plus b iota. So A will be 3 and B will be 2. It means we will check 3 comma 2, right? This point having coordinates 3 comma 2 will lie in which quadrant? So here both are positive. So this will lie in first quadrant. Similarly, if we are having minus 4 plus 3 iota, look at this one. So this is what? This is minus 4 comma 3. Similarly, minus 2 minus 3 iota. This will be what? This will be minus 2 comma minus 3. If we take example of fourth quadrant, so in fourth quadrant, x is positive and y is negative, right? X means the real part. So here it is what? 2 minus 3 iota. Suppose we are taking 2 minus 3 iota. It means this will be what? This will be 2 comma minus 3, right? So real part is 2, right? And imaginary part is minus 3. So this will be the position of what? 2 minus 3 iota, right? So in this way, we can easily represent any complex number graphically. That is on Argand or complex plane. Now let us start our today's session. If I talk about objectives of this lesson, so by the end of this lesson, students will be able to understand what is the modulus and conjugate of complex numbers. So they will be able to understand polar form of complex numbers. Then students will be able to understand argument of complex numbers. And at last, this is very, very important. We will discuss many practice problems based on today's topics. Now we will discuss few key concepts related to today's lesson. Yes, first one is modulus of a complex number. If we talk about the general form of complex number, it is z is equal to a plus iota b, right? And what is modulus of complex numbers? The modulus of a complex number is its distance from the origin on the Argand plane. If we talk about origin, so on origin, both real part and imaginary part will be 0 and 0. And this is the point P. Here, complex number is a plus iota b, right? So if 0 comma 0 and a comma b, how to find distance between 2 points? If we are having x1 y1, this is point a, and point B is having coordinates x2 comma y2. So then the distance between A and B, that is equal to, yes, x2 minus x1 whole square plus y2 minus y1 whole square, right? Here x2 is what? A, and y2 is B. X1 y1 are 0 0. So mod z, distance from this 0 to b, modulus of complex number. So this is represented with this sign, right? So mod z is equal to under root a square plus b square. This formula is very important, right? I hope everybody is clear. Let us move to next slide. So here we will discuss conjugate of complex numbers. The conjugate of a complex number is its reflection across the real axis on the Argand plane, right? Look at this one. This is z is equal to a plus iota b. If we talk about its reflection across the x-axis, so here you will see x coordinate will be same. You can write the coordinates a comma b, right? So on this line, this is a vertical line parallel to y-axis, right? The distance from this point to z is b. So now we will go down b units. Now we will go b units down from x-axis, right? But here it is what? It is negative y-axis, right? So here what we will do, a will be same, but we will change the sign of imaginary part, right? So it is a minus iota b. Or in this way, you can easily understand conjugate of complex number. This one, a plus iota b, is the given complex number. If we have to find the conjugate of a plus iota b, what we will do? We will simply change the sign of imaginary part. Here, imaginary part is b plus b, right? So while we will find the conjugate, its sign will be negative. If a minus b iota is the original number, so then after finding conjugate, it will become a plus b iota. What we have done, we have changed the sign of imaginary part. It was minus b. Now after finding its conjugate, it will be a plus b iota, right? You can understand in this way. Suppose you are having 2 plus 3 iota. This is a complex number. Then conjugate is always represented in this way, right? So this will be what? We will just change the sign of imaginary part. If we are having z is equal to 3 minus 4 iota. Then conjugate of z will be what? Real part will be as it is, and imaginary part it is -4. So this will be +4 iota. Right? This is very simple. Let us move to next slide. Now it is polar form of complex number. Always remember, in polar form, a complex number is written as z is equal to r into cos theta plus iota sin theta. Right? What is the original form of complex number? It was z is equal to x plus iota y. It means, what is x? X will be equal to r cos theta. What is y? Y will be r sin theta. Right? If we talk about modulus, so what was the modulus? In this case, yes, it was modulus was x square plus y square under root. If we square these equations, what we will get? X square is equal to r square cos square theta and y square is equal to r square sin square theta. Right? I'm writing here. X square will be what? It will be r square cos square theta and y square will be r square sin square theta. If we add these two, what we will get? X square plus y square. This will be equal to what? R square cos square theta plus r square sin square theta. R square is common, so I am writing r square into cos square theta plus sin square theta. We know cos square theta plus sin square theta is what? It is equal to 1. So x square plus y square will be equal to what? It will be equal to r square. Right? Here r is called modulus. R can be written as, how to find the value of r? Yes, r is equal to under root x square plus y square. And what is the value of under root x square plus y square? It is mod z. It means r is the modulus. Whenever we have a complex number which is written in its polar form, then always remember r is called modulus. Right? And it is simply the distance from origin to the point x comma y, just like we were doing for this number. Right? Theta is called the argument. Right? Look at this angle, theta. This angle is called argument. It means it is angle between the positive real axis and the line segment joining the origin to x comma y. Right? Here it was what? Joining this x comma y, and here x will be what? X will be r cos theta and y is r sin theta. Right? So theta is the argument. Let us understand this argument in detail. Look at this one. Whenever we talk about argument, we have principal and general argument. Right? What is principal argument? Yes, principal argument is what? It is also called amplitude of z. Right? So principal argument of complex number is always lies between minus pi to what? Plus pi. Right? Amplitude is what? Or principal argument we had already discussed, it is theta. Right? So minus pi is not included, means theta is what? Theta belongs to minus pi is not included, but pi is included. Means value of principal argument can be pi, but it cannot be minus pi. Right? Now look at this one. Principal argument of complex numbers has values 0 to pi. If taken in the first two quadrants where the angle is measured with respect to the positive x-axis in the anti-clockwise direction. right? What does it mean? Look at this one. We are having two quadrants, first and second. If we take, if angle is measured with respect to positive x-axis in anti-clockwise direction, it means they are talking about angle is measured in this way, right? So in that way, principal argument will always be positive, right? Look at this one. It is minus pi to 0. In the third and fourth quadrant, when it comes to third and fourth quadrant, right? So then we will measure argument in this way, because they are talking about what? It is measured in clockwise direction. So here, if it is in third and fourth quadrant, then principal argument will be negative, right? In first and second, it will be measured what? In anti-clockwise direction. But in third and fourth, it will be measured clockwise direction. I hope this is clear. In first and second, theta will be positive, means principal argument will be positive. But in third and fourth, principal argument will be negative. Clear? Next one is general argument of complex number. How to find general argument of complex number? It is simply theta plus 2n pi, where n is an integer. Theta is what? Theta is principal argument, or it is what? Amplitude of z, right? So how to find general argument of a complex number? It is amplitude of z plus 2n pi, where n belongs to integers. I hope everybody is clear about principal and general argument, right? So if we talk about key concepts, so we had discussed modulus of complex number, then conjugate of a complex number, how to write a complex number in a polar form, and what is principal and general argument. Now it's time for practice. I hope everybody is ready. Yes, this is your question number 1. Find the modulus and the argument of given complex number, right? I will tell you a very easy way to solve these questions. Look at this one. This is what? This is real axis and this is your imaginary axis, right? Look at this one. Z is equal to -1 minus iota root 3. This is your Argand plane. Now, this is what? In terms of coordinates, it will be -1 comma minus a root 3, right? Both are negative. It means, yes, it will be in third quadrant. If we talk about -1 and minus root 3, yes, tell me, this will be, what is the position of this one? It will be like here, right? And this is Z. What is the first step? We will just join this complex number Z with origin, right? Now, origin is having coordinates 0, 0. And this one Z, what are the coordinates? It is -1, minus under root 3, right? If we talk about modulus, so what is modulus? Modulus is simply, if we compare this with what? X plus iota y. So modulus Z is x square plus y square under root. And this will be what? It will be -1 square plus minus iota 3 square. This will become what? 1 plus 3, and under root 4 is what? Under root 4 is 2. It means modulus will be 2, right? Now coming to argument. Argument is what? Argument means theta, right? So this is in third quadrant. And theta is what? This will be theta. Theta is the angle made with positive real axis. Look at this one. So this will be your theta. So we are going in this direction, means we are in third quadrant. So it will be clockwise direction. And your theta will be what? Final value will be negative. Your answer will be negative, right? But to find this theta value, what we will do, we will draw a perpendicular from Z to this negative real axis, right? Now look at this one, minus 1 comma minus under root 3. Can you tell me, suppose this is your P, OP and PZ, right? So here X will be what? X coordinate is minus 1. So OP will be what? OP is the distance. So it will be 1. And if we talk about PZ, it will be under root 3, right? So to find theta, first of all, we will find this angle. Suppose this is alpha, right? Alpha will be what? Alpha will be, yes, if we find tan alpha. So tan alpha is what? Tan alpha will be under root 3 upon 1, right? If tan alpha is under root 3, so alpha will be tan inverse root 3, and directly you can write the answer. This is equal to pi by 3. Always remember, we will consider theta in radians, right? So it will be pi by 3, right? So if alpha is pi by 3, and look at this one, alpha plus theta, this will be equal to what? This will be equal to pi radian, means they will make straight angle 180 degree, and that is equal to pi. And already alpha we have calculated, it is pi by 3. Theta will be what? Theta will be pi minus pi by 3, that is equal to 2 pi by 3. But look at this one. We had already discussed, when principal argument is in third or fourth quadrant, then theta will be negative. So what is the argument of this number? This will be, theta will be equal to minus 2 pi by 3, right? I hope everybody is clear. Let us solve next question. Find the modulus and the argument of given complex number. Z is equal to minus under root 3 plus iota. So we have solved same question. So now what will be the first step? We will compare given complex number with its standard form. So that is x plus iota into y, right? So here x is what? X is minus under root 3 and y is, yes, it is iota into 1. So y will be 1. So what is modulus? Yes, modulus is x square plus y square under root. Now tell me, what will be the answer? X is what? Minus under root 3 whole square, and this will be what? 1 square, right? So this will be what? This will be 3 and this will be 1. So we are having 4 So what is modulus Z? It is equal to 2, right? So what is modulus? It is 2. Now we have to find argument. To find argument, what is the first step? Yes, we will draw the Argand plane. Yes. So this is the Argand plane. And now if we write minus under root 3 plus iota in terms of coordinates, so then we will have real part is minus under root 3 and imaginary part is 1, right? So now if we talk about real part is negative and imaginary part is positive, so this is the real axis, these are the imaginary axis, right? So here it will be what? It will be in second quadrant. Second quadrant means real part is negative and imaginary part is positive, right? So if we roughly make this complex number, so this will be the Z minus under root 3 comma 1, right? So now what is the next step? We will join this complex number with origin, right? Now we are in second quadrant. So then argument. Argument means theta will be in, yes, it will be in anti-clockwise direction. So this is the value of theta, right? But first of all, before finding theta, what we have to do? We have to calculate alpha. Yes. Just remember these steps. Steps are very easy. You can solve all the questions then. So now, yes, this will be 90 degree. So then suppose it is P. So then OP means OP is, yes, X coordinate. So length, it is what? Simply under root 3 and Y coordinate. So it is PZ will be 1, right? So now, yes, tan alpha will be what? 1 upon root 3, right? If tan alpha is 1 upon 3, so easily you can find alpha. Alpha is equal to pi by 6, right? Now this is what? This is a straight angle, means alpha plus theta is equal to 180 degree, right? But you know, here everything will be in terms of radians, right? So 180 degree means pi radian. And we had already calculated alpha. So theta will be what? Theta will be pi minus alpha, and that is pi by 6. So what is theta? Theta will be 5 pi by 6, right? And this is the required argument. Is this clear? I hope everybody is clear. Modulus will be 2 and argument will be 5 pi by 6. So let us move to question number 3. Question number 3 is convert the given complex number in the polar form. So we have to convert the given complex number in polar form. Polar form is what? Yes, it is r into cos theta plus iota sin theta, right? So here what we have to do? We have to find r and theta. Theta we are already calculating. Theta is what? Theta is the principal argument, right? And r is what? R is, yes, R was what? We had already discussed R is the modulus. So in this question, we are not doing anything new. First of all, what we will do, just like previous two questions, we will find its modulus, then we will find its argument, right? Now, just like previous question, how to find modulus? Yes, we write the given complex number in its standard form, right? So if we compare this one, so x is 1 and y is what? Y is imaginary part. So that is -1. So what is r? Yes, r is mod z, and modulus z is what? Under root 1 square plus minus 1 square. Right? And this will be what? This will be 1 plus 1. Right? So r will be what? R is mod z, and this is under root 2. It means, first of all, the value of r, that is equal to under root 2. Right? R is nothing, but it is the modulus. Now coming to theta. Yes, how to find theta? Yes, first of all, we will make our, yes, we will make the Argand plane. So this is real axis and these are the imaginary axis. If we write the given number, complex number was what? 1 minus iota. So we will write it in, yes, coordinates form. So real part is 1 and imaginary part is -1. So 1 comma -1, right? So real part is positive and imaginary part is negative. So tell me, this will be in which quadrant? Yes, yes, very good. This will be in fourth quadrant. Here, real part is positive and imaginary part is negative. Very good. So here, if we make this one, so this is what? This is your 1 comma -1. What is the next step? Yes, same, just we were solving previous two questions. We will join origin and this z together, right? Now tell me, we are in fourth quadrant. We will go clockwise or anti-clockwise direction, right? So we measure our angle with positive real axis, right? So if we go in this direction, suppose in this way, what we will get? Yes, it will be more than pi. And we know theta is what? It will be, this is the range of principal argument, right? So it will be more than pi. So now what we will do? We will measure our argument in what? Clockwise direction, right? So this will be the value of theta. But if it is in clockwise direction, so always remember theta will be negative, right? So now how to solve? We will join the perpendicular, and this is what? This is 1. This, suppose this is P. OP is 1 and PZ is also 1. So what is your tan theta? Yes, tan theta will be equal to 1 upon 1. So it is 1. It means what is theta? Theta will be pi by 4. What we had already discussed, we are moving in what? Yes, clockwise direction. Since theta is less than 0, this thing implies theta will be minus pi by 4. Very good. So this will be the argument of z, right? And what is the required polar form? Simply we will substitute value of r, that is what? That is under root 2. And what is cos theta? Theta is minus pi by 4 and plus iota into sine minus pi by 4. And this is the final result. I hope everybody is clear. In this way, we can solve questions related to polar form. Right? Let us try another question. Yes, convert the given complex number in the polar form. Same. What is our target? We will express this complex number in the form of r into cos theta plus iota into sin theta. Right? Now, what is the next step? Yes, we will find the value of r. R is nothing but it is modulus z, right? So directly I am writing it is what? Under root, real part is -1. So minus 1 square plus imaginary part is 1. So it is 1 square. So what is the final value? It will be under root 2. It means what is r? R is under root 2. I hope everybody is clear till this point. What is the next step? Yes, next step is what we will do. We will write the given complex number in terms of coordinates. So what is the real part? It is -1 and imaginary part, it is 1, right? So now -1, 1 is the coordinate of a point. So now we will make the Argand plane. Yes. So this is your real axis and these are the imaginary one. Now check -1, 1 means real part is negative and imaginary part is positive. Yes. So this will be in second quadrant, right? So let us represent this -1, 1, right? So this is your Z. And now what is the next step? Yes, we will join Z with horizon. Now we are in second quadrant. Now tell me what will be theta? Yes, theta will be, yes, this angle made in anti-clockwise direction, right? So here, this will be your theta and the value of theta will be positive, right? Because we are going in anti-clockwise direction, right? We measure theta with what? This OZ and this real axis of Argand plane, positive real axis of Argand plane, right? But before finding theta, what we do? We find the value of alpha, right? So now look at this one. Here it will be 1 OP. This will be 1 and ZP is also 1. Now what is tan alpha? Tan alpha is equal to 1 over 1, right? It means tan alpha is 1. So alpha will be equal to pi by 4, right? It means alpha plus theta is equal to, yes, it was pi and alpha you have already calculated. So theta will be pi minus pi by 4. And the value of theta will be 4 pi minus pi. Yes, it will be 3 pi. And 3 pi upon 4 is the principal argument, right? So we were in the anti-clockwise direction. So theta was positive. Now there is no need to change the sign of this argument. So now what is the final result? Yes, what is the value of r? R is under root 2 and your cos 3 pi by 4 plus, yes, it is iota into sine 3 pi upon 4. Yes. So this is the final required polar form of given complex number. I hope everybody is clear now. Now you guys can easily solve all the questions related to complex number, right? We have solved in initial two questions. What we have done, we had found simply modulus. It is given, find the modulus and find its argument, right? But in question number 3 and 4, we have to convert given complex number in polar form, right? So in polar form, we were doing same just like in first and second question. We were finding r. R is what? R is modulus z. And theta is same just like previous one. It is argument. Yes. So let us discuss another question. Question number 5 is convert the given complex number in the polar form. right? So just like previous question, what we have to do, we have to convert this into r into cos theta plus iota into sin theta, right? Now, what is the first step? We will find r, and r is modulus z, right? So how to find mod z? Yes, it is under root of what? Real part is -1, so -1 square plus imaginary part is also -1, so -1 square, right? So -1 square, it is 1, 1 plus 1, it is 2, right? So r will be what? Under root 2, right? Now we will find the value of theta. Theta is what? Theta is the argument. And what we will do? We will write the given complex number in the form of a what? Coordinates. So there is a point z having coordinates -1, -1, right? -1 is real part and imaginary part is also -1, right? Now what we will do? We will draw an Argand plane, right? This is the real axis and this is the imaginary axis, right? So look at the point. Point is z having coordinates -1, -1. Both real part and imaginary parts are negative. It means this point z will be in third quadrant, right? So what is the next step? Yes, we will join this z with origin, right? So z is having coordinates what? -1, -1. Now we are in third quadrant. So if we talk about theta, so we will reach here by what? Clockwise direction. So this angle will be theta, right? But we are in third quadrant. So before finding theta, we have to find alpha, right? So suppose this is what? This is P. So PZ will be 1 and PO is also 1. So can you tell me what will be the value of tan alpha? Yes, tan alpha will be 1 upon 1. Means it is tan alpha is 1. If tan alpha is 1, easily we can find the value of alpha. That will be, yes, that will be pi by 4. Right? Now, another thing. We have moved what? In clockwise direction. So first thing will be theta will be less than 0, means theta will be negative, right? So look at this one, alpha plus theta, that will be what? That will be equal to 180 degree, and that is what? Pi radian. And theta is what? Theta will be pi minus, yes, what is alpha? It will be pi by 4. And we had already discussed value of theta will be what? Value of theta will be negative. So I'm adding negative outside. So what is final value of theta? Yes, I'm writing here. It is minus 3 pi upon 4. This is the argument of complex number, right? So what is the required polar form? Yes, R is what? R is under root 2. And what is theta? It is minus 3 pi upon 4, right? Plus iota into sine minus 3 pi upon 4, right? So in this way, we can write its polar form, right? I hope everybody is clear. So let us move to next question. Question number 6. Convert the given complex number in the polar form just like previous question, but you can see the complex number. Here, z is equal to -3. Means it is what? It is purely a real number. And we can write it as 0 into iota. Right? Now we want to write this in the form of r into cos theta plus iota into sin theta. Now what is the next step? Yes, we will find r, and r is what? R is mod z. Now this time it is very easy. What is the real part? Yes, real part is minus 3. So minus 3 square plus 0 square. Right? So what is minus 3 square? It is 9, and 9 plus 0 is simply 9. So what is r? R will be equal to 3. I hope everybody is clear. Right? What is the next step? Yes, the next step is we will write the given complex number. Given complex number is minus 3 plus 0 into iota in terms of what? In terms of coordinates. So it is minus 3 comma 0. What is the next step? Yes, very good. We will make the Argand plane to represent this coordinate, right? So this is your real axis. These are the imaginary axis. And now minus 3 comma 0. Minus 3 comma 0 is not in any of the quadrant, right? This is your first quadrant. This is your second quadrant. This is your third quadrant. This is your fourth quadrant. But minus 3 comma 0 will be on, yes, real axis, on negative side, right? Because here you are having minus 3 comma 0. So this will be your z, right? Now tell me, this is your z. And what we do to find theta? Theta is what? Theta is the argument. What we do? We make angle with positive real axis to this point. So this is what? This is the line. If we join this with the origin, look at this one. Now, majority of students, they will say, sir, we will come in this direction, or some students, we will come in this direction. At this point, this question is very tricky. We have to write the range. Range is what? Minus pi is less than theta, is less than or equal to positive pi. Whenever we have to choose minus pi and pi, you can see minus pi is not included. Theta can never be equal to minus pi, but theta can be equal to pi. If theta can be equal to pi means we are coming in which direction? Yes, it will be in anti-clockwise direction. So this will be the value of theta. Here directly there is no need to find any alpha. So directly you can write theta is what? Theta is equal to, yes, pi. And theta is equal to pi means easily we can represent the given number in terms of polar form, right? So what is r? R is 3 and cos into theta is pi plus iota into sin pi. And this is your required polar form. I hope everybody is clear. So this question is very tricky. You have to be very, very careful, right? So let us move to next question. Question number 7 is convert the given complex number in the polar form, right? So what we want to find, we want to convert this given complex number in the form of polar form, right? So this is what? R into cos theta plus iota into sin theta, right? And what is the first step? Yes, we will find R. R is what? R means, yes, mod Z. And modulus Z means, yes, very good. It is simply real part is under root 3 square plus imaginary part is 1. So it is 1 square, right? So this is what? This will be 3 plus 1, 4. So directly I'm writing R is what? R is 2, right? Now what is the next step? Yes, we will represent the given complex number. This is what? Under root 3 plus iota in the form of a point. So point will be what? Point will be Z having coordinates under root 3 comma 1. What is the next step? Yes, quickly. Yes, we will make the Argand plane. This is real axis and these are the imaginary axis. And we will check under root 3 comma 1. It is in which quadrant? Both are positive. It means it is in first quadrant, right? So if we roughly sketch this one, so this will be somewhere here under root 3 comma 1. So this is your Z point, right? What is the next step? Yes, we will join Z and O together, right? Now, what is the next step? We will make our angle theta. Theta is what? Theta is the argument. And look at this one. Here, we will make angle theta with positive real axis. So here, yes, very good. We will go in anti-clockwise direction. So this is your theta, right? So we have moved to anti-clockwise direction. So theta will be positive. And look at this one. This is very easy question. Here we don't have to make alpha, right? Directly we will calculate the value of theta. So look at this one. Z is having coordinates root 3 and 1. So if this is P, so OP will be what? X coordinate, it is under root 3 and Y coordinate is 1. So now what is the next step? Yes, we will find tan theta. And what is tan theta? Yes, it is 1 upon root 3. If tan theta is equal to 1 upon root 3, so then theta will be equal to pi by 6, right? And it will be positive. So this is the final value of argument of Z. So now what we want to write? We want to convert this in polar form. So first of all, we will write the value of R. It is 2. So 2 into cos pi by 6 plus iota into sine pi by 6. And this is your final answer. I hope everybody is clear. So in this way, you can solve all these questions very easily, believe me, if you will remember all these steps, right? Steps are very easy. Now let us move to next question. Here, we have to convert the given complex number in the polar form, right? But look at this one. The complex number is what? Z is equal to iota. It is purely imaginary number, right? So we can write it as 0 plus 1 into iota, right? So mainly we want to convert this into polar form. And what is polar form? It will be R into cos theta plus iota into sine theta, right? So now what is your first step? Very good. We will find R. R is nothing but it is modulus Z, and modulus Z will be what? Yes, real part is 0. So 0 square plus 1 square. So simply it will be what? 1. So what is R? R is 1. What is the next step? Yes, we will write this Z is equal to 0 plus 1 into iota in the form of a point. So point is Z and having coordinates 0, 1. right? What is the next step? We will make the Argand plane. So this is the real axis. These are the imaginary axis. Again, 0, 1 will not lie in any of the quadrant. In fact, this will be in what? This will be on imaginary axis, on positive side, 0, 1. Right? So roughly Z will be here. It is 0, 1. And now what is the next step? Yes, we will join this Z with horizon. And we will make angle theta with what? With positive real axis. So here we are in between first and second quadrant, right? So what we will do? We will make our angle theta in, very good, it will be in anti-clockwise direction. So this will be your theta, right? And if your Z is here, so theta will be what? It is 0. And this is what? This will be pi by 2. This is your pi, right? So here directly we will write theta is what? Theta is pi by 2, right? So we have calculated R and now we have calculated theta. So theta will be pi by 2 and which will be positive because we have made theta in which direction? It is in anti-clockwise direction. So theta will be positive pi by 2. So what is your final answer? Yes, R is 1. So 1 into cos pi by 2 plus iota into sine pi by 2. In this way, you can write this complex number in the form of polar form, right? I hope everybody is clear. So this is all about your today's session. So we have completed complex numbers. Thank you so much. If you enjoyed this session, so then hit the like button and share this lesson with all your friends in case of any type of query or any type of suggestion. You can use the comment section, and for more interesting videos, you can subscribe our channel Arena World Education. And thank you so much. See you in the next session. Bye bye. Take care.